So now another example, we want to find all relative extrema using the first derivative test. F of x is equal to x squared over x squared minus 25. So first thing we want to do is find the derivative f prime of x and set that equal to 0. So in order to do this, we have a function of x divided by a function of x, so we're going to have to use the quotient rule. Quotient rule, low d high minus high d low. So the low is just the denominator, copy and paste the denominator, x squared minus 25. Multiply it by the derivative of the top, that's the d high part, minus high d low, so you copy the x squared and multiply it times the derivative of the denominator. Derivative of x squared minus 25 is 2x minus 0. And then everything is divided by the denominator squared. So now we can just simplify this equation. I'm going to distribute that 2x into the parentheses to the left of it. 2x times x squared is 2x cubed. 2x times negative 25 is negative 50x. And then on the right, subtracting 0 doesn't do anything, and I can just multiply the 2x with the x squared. So that would be 2x cubed, and then there's a negative in front of it. Negative 2x cubed, all over x squared minus 25, quantity squared. In the numerator, the 2x cubes cancel each other out, so we just have negative 50x all over x squared minus 25, quantity squared. So now that that is our simplified derivative, we can set it equal to 0. If we multiply both sides by x squared minus 25 squared, that will cancel out the denominator over there on the left. And then on the right, 0 times anything is just 0. So that parentheses just kind of goes away. We're left with negative 50x equals 0. And then divide both sides by negative 50, and we find x is equal to 0. So that is our first critical point. Step 2, we want to check to see when does f prime of x fail. So f prime of x fails if you end up dividing by 0. So the derivative would not exist at that point. So all we really need to do on this step is just to take all of that denominator, x squared minus 25 squared, and set it equal to 0. So that would tell us only when the derivative fails. So we have x squared minus 25, quantity squared, is equal to 0. Take the square root of both sides. The square root cancels with the square. We have x squared minus 25 equals 0. Move the negative 25 to the other side of the equal sign. X squared equals 25. Take the square root of both sides. That'll get rid of the squared on the x. So now we have x is equal to plus or minus 5. Those are two more critical points. So we have a critical point of x equals 0. We have a critical point of x equals positive 5 and another one at negative 5. So step 3 is we want to do a sign test on those 3 critical points. So we draw a number line, and on that number line we want to plot each of those 3 critical points, negative 5, 0, positive 5. I'll put the negative 5 on the left, positive 5 on the right, 0 goes in the middle. So below the number line, these are values of x, and then above the number line, I'm going to write attributes for f prime of x. So now above the 0, we write a 0 because the derivative was 0 at that point. At negative 5, it failed, so we can write a d and e above negative 5, and then above the positive 5, write another d and e. I need to create some new points to test. So to the left of negative 5, I'll choose negative 6. Between negative 5 and 0, negative 1 would be an easy one to use. Between 0 and 5, I'll choose 1. And then to the right of 5, I'll choose 6. I need to test each of these new x values in f prime of x. So I'll do f prime of negative 6. That would give me negative 50 times negative 6 over negative 6 squared minus 25 quantity squared. So that numerator, negative 50 times negative 6 is 300. And you know what? The denominator, we really don't even have to solve that out, because we know that that whole denominator is being squared. Whenever you square something, it doesn't matter what's going on inside that parentheses, that's going to end up positive. So we end up with a positive on the denominator. We know the numerator is positive. So our answer is going to be a positive number divided by a positive number, which is a positive number. And when we're doing the sign test, we really don't care about the exact value of this. We only care about the sign. So I'm just going to put a plus sign above the negative 6 and then move on to the next x value. So f prime of negative 1 is equal to negative 50 times negative 1, all over that parentheses squared, negative squared minus 25 quantity squared. The numerator is negative 50 times negative 1, so that's a positive 50. But remember, we only care about the sign, so really the numerator is just positive. The denominator is all being squared, so we're going to get a plus sign in the bottom. And then a positive number divided by a positive number is a positive number. So I'm going to put a plus sign above the negative 1. Now we can move on to x equals positive 1. F prime of positive 1 would be negative 50 times positive 1 all over that denominator squared. So 1 squared minus 25 quantity squared. So the numerator, negative 50 times 1, that's going to give me a negative 50. So the numerator is negative. The denominator, we know it's going to be positive because everything's being squared in the bottom. So a negative number divided by a positive number is negative. So I'll put a negative sign above the 1. And then we can move on to f prime of positive 6. So negative 50 times 6 over the denominator squared. So the numerator, a negative times a positive, is going to be a positive number. Sorry, it's going to be a negative number, and then the denominator is going to be positive. So I get a negative divided by a positive. So the answer for that is going to be negative. Put a minus sign above the 6. So let's bring it all together now. So if you look at the critical value of negative 5, to the right of negative 5 is positive, to the left is positive. So at negative 5 itself, there is no change in sign. And I'm writing saddle point here, but that was actually a mistake. There's actually a vertical tangent here, so it's not exactly a saddle point. So disregard me writing a saddle point for that. And then at x equals 0, it was positive to the left, negative to the right. So if f prime goes from positive to negative, that means that we have a relative max at that point. And then finally, at x is equal to positive 5, it's negative to the left, negative to the right. So that means that there is no relative min or max at x is equal to 5. And it's not a saddle point there either. It's actually just another vertical asymptote. So finally, let's just bring it all together. Since f prime of x changes from positive to negative at x equals 0, that means that there is a relative max at x equals 0.